Welcome to this video on distributions of the sample proportion, part 3. Let's begin. By the end of this video, you should be able to determine whether a word problem meets all the requirements of the sampling distribution, and use a sampling distribution of a sample proportion p hat to find the probability of events. Example 2. It is widely accepted that approximately 11% of Americans are left-handed. What is the probability that in a sample of 150 Americans you find that more than 14% are left-handed? So first we have to go through and make sure all of our requirements are met. First of all, there have to be two possible outcomes, which we will define as success and failure. So we will define success as being left-handed and failure as being not left-handed. Again, remember, success in statistics is not the same as success in real life. In general, success means that, oh, good job, you did great, right? There's a connotation of something positive. And again, in statistics, success is merely the presence of an attribute, and failure is its absence. So a lot of times in medical trials, we would say success is the presence of a disease, whereas failure is the absence of it. So please don't be offended if you're not left-handed. Again, this is just the way we define success and failure, presence and absence of an attribute in statistics. Okay, so then we say the trials must be independent, and we achieve this by saying that the sample size has to be less than or equal to 5% of the overall population. So I think it's reasonable to say that there's more than that 150 Americans, right, is less than 5% of the overall population, for sure. Okay, so then we have to make sure that the probability of success, in other words, probability of encountering a person who's left-handed, is constant. And again, we can say that that is true. We know that the population proportion of left-handed people is 11%. There also has to be a fixed number of trials, which is our sample size, and that is 150. So then we also have to worry about making sure that there is at least 10 successes and 10 failures. So remember, our sample size is 150. The population proportion is 11%. And so Q is 1 minus P, or like the proportion of people who are right-handed or not left-handed. So that's 89%. So the number of people in this sample size who are expected to be left-handed is 16.5. So that's more than 10, right? So more than 10 successes and more than 10 failures. So we can assume that the sampling distribution of p hat will be normally distributed. So now that we have met all of our requirements, we can go on and actually do our answer this question, right? So in order to answer the question, we have to do some math. So first of all, we have to find what is the population proportion in this question. So I encourage you to pause this video, see if you can figure it out, and then unpause it. Then we have to find our sample size, n. We have to find our sample proportion, and then we have to use all of those values to calculate our population standard deviation. So what is our population proportion? Well, it's 11%, right? 11% of Americans are left-handed. Okay. Then we have to figure out what is our sample size. Well, our sample size is 150. Then we have to figure out, well, what's our sample proportion? Well, our sample proportion is 14%. And again, it's associated with our sample size, not with the overall population. So let's summarize our information. So the population proportion is 11%, or 0.11. The sample proportion is 14%, or 0.14. The sample size is 150. So remember, we treat the sampling distribution, the mean of the sampling distribution is the population proportion. So if you think of that normal distribution, like picture the bell curve in your head, that p, the 0.11, is going to go in the middle. That's our expected value. Then we have to calculate the standard deviation using these values. So we fill in the population proportion p. We calculate q by doing 1 minus p. So 1 minus 0.11 is 0.89. And then we divide by 150. So again, remember, p is the proportion of successes, q is 1 minus p, the proportion of failures, and n is the sample size. So when we plug that into a calculator, this is the value we get. And as always, we're going to have to round at some point. And my recommended value is to round to 4 decimal places. So if you are doing a manual calculation, you might just pop all those values into this formula and find a z-score, then put it in a z-table to find the area under the curve, and think no more about it. But I want to take a minute and look at technology so we can process a little bit more what we're really doing. So regardless of what technology you're using, you are going to go to the normal calculator. And remember, normal calculators ask you for a mean and standard deviation. For example, here's the one in our Guru. If I go over to StatCrunch, It's going to ask me for a mean and standard deviation here as well. So what on earth are we going to do? What is our mean? What is our standard deviation? Well, our mean is not really a mean, right? Because remember, we're working with qualitative data, but we treat the population proportion as the mean, the expected value. So that's what we're going to type in for mean, even though we know we're working with categorical or qualitative data. Then the standard deviation is what we calculated. And then our random variable, the line that we're going to draw on our normal curve, and then shade left, shade right, shade in between, is our sample proportion. And of course, as far as our inequality, we just look for our keywords in our problem statement. So in our problem, it said, what is the probability that more than 14% of the sample are left-handed? So that would be greater than or equal to or above. So let's go back to our technology and see if we can generate a picture of what we're looking for. So as I said, we are treating our population proportion as our mean. It's going to go into the center of our distribution. So again, 11% of Americans are left-handed. Then we calculated our standard deviation, so we can type that in. And again, we want to select from the drop-down menu. We want to select above because we want to know what is the probability that more than 14% of that sample of 150 people are left-handed. Okay, so I could just hit this I and then I get the probability, but again, I just love this visualization. And honestly, even if you're doing just the manual calculations, you should be, drawing a picture. Draw a picture, sketch the normal curve, and then label it so that you can get a visualization of what you're really doing. So let's go ahead and hit this eyeball. Okay, and the probability is here. And as you can see, the shaded region, the area under the curve, is 0.1197, which is about 12%. So there's about a 12% probability that if you have a sample of 150 randomly selected people, that more than 14% of those people will be left-handed. And again, we can also do this in StatCrunch. You know me, I love my StatCrunch because it gives me that visual, and I like it especially because when I hit compute, I can hit this button, and I love that it puts that mean in the middle, and then each tick mark is one standard deviation from the mean. So to me, that's just a superior way of displaying the information. So from the results we got, either by using the formula and calculating it by hand and using a z-table, or by using technology, we can say that the probability of a sample of 150 randomly selected people, that it results in more than 14% of people who are left-handed, is about 12%. And again, that's just rounding this value to the nearest percent. So now that you've watched this video, you should be able to determine whether a word problem meets all the requirements of a sampling distribution, and you should be able to use that sampling distribution of a sample portion to find the probability of events.